Okay, so now let's go on to your resolving vectors into its components. So the last meeting we learned on how to solve for the reaction or how to get the reaction. So the sum of the forces or the sum of, let's say, two or three forces results to a resultant force. And again, you may add them using vector property, vector operations. And we also discussed the different vector operations. So again, in adding vectors, so it's not the same as adding as 1 plus 2 is equal to 3, but you'll be using geometry na mga formulas such as the sine law and the cosine law for us to be able to solve the magnitude or the value of the resultant force. Okay, so let's go into resolving vectors into components. So I think this topic is important because, let's say for example, you are about to design your elements in your building, and for example, it's a roof. So the roof will be subjected into a um, diagonal load, wind load. So you have to break down the forces into its vertical and horizontal component because that will contribute into different aspects in your um, structure, such as the wall, the weight of the building, the weight of the roof. So that's why it's important to resolve also the forces, not just by getting its resultant. Okay, so again from last meeting, so we have learned that um, your F is the resultant force is the sum of the force components. Okay, or again in the last meeting we added the forces to get a resultant. Okay, or let's say it's in the R variable. Now this time from the resultant force, we're going to break it down into its vertical and horizontal components. So again, why is this important that we resolve our forces or we break down our forces? So for example, we have this triangle here. Let's say this is your roof. So again, as mentioned, let's say you have a wind load here, wind load. So again, I think it's easier for us to determine the force distribution if we break down our components into its corresponding vertical and horizontal components rather than analyzing your force by its vertical, I mean by its diagonal component. So again, it's easier for us to determine the horizontal and the vertical load of the wind later because again, the purpose of which is for the force distribution on the other elements of your structure. And I think in it's much easier for us to be it's much easier to understand the distribution of forces if we have horizontal and vertical components of our load. Diba? Going up, going down, going right, and going to the left forces rather than analyzing diagonal forces. Okay. So again, for the special cases for our vector components, resolving vector components. So for example, we have two given components and then one component is unknown. So this is one reason also that we analyze a vector into its components. Okay, so let's say we are just concerned with the vertical load only and the given is the the diagonal load, di ba? So for example, the given is diagonal ang load ang given. Then we're only interested in the vertical load. Kanina to pangitaon. So we need to resolve it into its components. Okay? So in the other case, the line of action of both components is known. So if both our components are known, so it's easier for us to resolve the components. So So more likely later on we'll be analyzing your forces using basic trigonometry. So tangent and then Pythagorean theorem, so on and so forth. So the same as the last meeting, but again we are just breaking your resultant first. I mean your resultant forces into its vertical and horizontal components. Okay. So for example, we have this diagram here. So we have four forces. So F1, F2, F3, and then F4. So again, these four forces are not yet the resultant force, but they are just the component forces of your resultant. So for example, if you want to break down each force into its vertical and horizontal forces, so what we need to do is, again, we are going to use some basic mathematics. So as you can see here in the second diagram, so for example, we take one force, let's say this one is F1. So to determine your f of x, so x is in the direction of the x-axis, then f of y is the force in the y-axis direction. So it would be going up and going down. So the tip here is, for example, your force is going upward to the right. So obviously your vertical force is going up and your horizontal force is going right because of this direction here. Diba? So for example, if it's going to the left, so going up, then going left. Okay. So again, if we try to resolve the forces into its corresponding vertical and horizontal forces, so what we need to do is we just use our Pythagorean theorem. So let's say we have this angle here, angle theta 1. So again, but if your force 1 is given, so you can just use sine or cosine function. So let's say sine theta is equal to f of y all over f1. Or if you're going to solve for the horizontal component, you're going to utilize the cosine function. Cosine theta is equal to adjacent side over hypotenuse. So that's f of x all over f sub 1. Now if you have two given components, let's say f1 and fy, so to get either parts of your forces is we can utilize the Pythagorean theorem. Okay, Pythagorean theorem. So again, if only one side is unknown, okay, then notice here your f of x is equal to f of h over r. So again, this is a cosine function here. Then this one is a sine function, v over r, vertical all over the hypotenuse, adjacent all over the hypotenuse. Okay, so muna siya ang mga formula. So let me write it again here. So again, to represent it even further, so your f of x is equal to f1 sine theta. Then this one is f cosine theta. Alright. So again, if we try to draw our different vertical components, so again, this one here, the horizontal component is in this direction. Then the vertical component is in this direction. So for force number 2, so since the force is in the second quadrant, going in this direction, so obviously this one is going up, but going to the left. Then your force number 3 is in the third quadrant, that's going downwards, going in this direction. So obviously going to the left, then going downwards. Okay. Then your force number 4 is in the fourth quadrant, so that's in this direction. So this one is going down, then going to the right. Okay. So I think this one is more easier because you have to break down your different components, and it's again it's easier compared to the last topic. So imagine that you have to connect four forces, di ba? Head to tail, tip to tail technique. Then you're going to determine your resultant force. So this will be a five-sided polygon. So one, two. So let's say force one, then force two, and then you have force three, then force four, di ba? Then you have the resultant, di ba? Resultant force. Then we don't know what the phase of your resultant force looks like. Kaya wata ka ba unsa siya, di ba? So let's say this one is your yeah. So this one is just for the sake of kuan lang. So instead of getting the trouble of getting this particular diagram, so we can come up with a simpler version. So upon getting the system components of your different forces, the horizontal and the vertical components, so we can summarize or we can add up all the horizontal forces and represent it as the x component of your resultant force. So in this manner. Okay, so that's why we have a summation of all the forces in the x direction. And again, this will represent the x component of your resultant force. And then next is we're going to add up all the vertical forces in your system components. So all vertical components will be represented by the vertical component of your resultant. So from here, so from the different forces, so again, if we try to break this one even further, so this will be f of 1x plus f of 2x plus f of 3x plus f of 4x. And then in your y component, this will be f of y of f of 1y plus f of 2y, f of 3y, then lastly is f of 4y. Okay, so next is, since we know that the resultant force is in a right triangle because this one is horizontal, this one is vertical, so we can just use Pythagorean theorem to get the magnitude of your resultant force, R. Okay, and then getting that angle from the x-axis. So since this one is horizontal, then this one is your vertical component, then this one is your resultant. So we can just use your Pythagorean theorem or your basic trig functions. Baliday. So this one is r of x, r of y. So in getting the theta or the angle going to your resultant force, so you can just use tangent function. So again, tangent function because that's opposite side all over adjacent side. So that's how you determine your resultant force. So again, from your system components, from vertical forces of your different forces, you add them all up, and also you add all the horizontal forces. Then once you have the resultant of the x components and then the resultant of the y components, then you use the resultant or then you use the Pythagorean theorem to get the resultant magnitude. And then you get the theta. So that again, the purpose of getting theta is you know where your resultant force is heading. You know the direction of your resultant force. So it may be, so let's say your theta may be 120 degrees. So meaning it's in the second quadrant. Or if it's less than 90 degrees, so your force is in the first quadrant, going upward to the right. So that's the importance of getting the angle for your resultant force. So you may be confused on all this diagram that I have presented. So for you to be able to appreciate, so let's go to an example. So let's say we have the four forces acting on bolt A. So we need to determine the resultant of the forces on the bolt. Okay. So to do this, so we need to first draw a FBD, your free body diagram. Okay, so your letter A can be represented by a dot. Okay, so again, I'm sorry for my drawing. Mga Archi students sa ba mo? So basin manaway mo sa akong drawing. Ito, so kamo lay perfect dia sa inyong notes if kana mo mag-kuan sa inyong. So again, this one is point A. Okay, so let's try to draw your different components. So your F1 is 150. So let's say this one is your 150 newtons. So again, this one is F1. The angle between it is 30 degrees. So next is we have a 100 Newton force in the fourth quadrant. So this one is 100 newtons. And then this one is F4. And then the angle is 15 degrees. Then we have a downward force of 110 kilonewtons. So this one is 110 newtons. F3. So it's in the 270 degrees angle or in the negative y-axis. Then lastly is your 80 newtons. So this one is 80 newtons and this one is force number 2. Then the angle between it is 20 degrees. So again, if you want to break down our components, so this will be the x value of the force number 1. This will be the y value of force number 1. So let's try to use different colors. So f of 1x, f of 2, f of 1 still. F of 1 y. So for force number 2, so let's use another color. So we have going to the left, then going upward. So F2y, F2x. So notice in force number 3, since it's going downwards, so it has no horizontal component, only a vertical component. So automatically your F of 3 is just equal to F of 3y since we don't have any horizontal component. And then lastly is your force number 4. So force number 4 is this one is so F of 4y, and this one is F of 4x. So it may be not clear, but let's try to break it down even further. So let's start with the first diagram. So my technique here for you to be able to understand the system, so not to look at the system as a whole, so you can draw it manually, I mean by force. So let's say starting with force number 1. Okay, so let's say this one is F1, that's 150 newtons. So this one is your F1y, this one is your F1x. Then this one is 30 degrees, right? So for us to be able to solve your components, so again by formula, so f of 1x is equal to f1 cosine theta. So that's 150 cosine 30 degrees. Then f of 1y, that's f1 sine theta, that's 150 sine 30 degrees. So solving the forces, so I'll just solve it for you so that you won't waste any time. So this one is 75 square root of 3. Then this one is 75. So don't forget the unit, newtons. So this is for the first force. So getting into the second force, so that's a green color. So let's try to draw the second figure. So this one is 80 newtons. Okay. So vertical component. So always go in line with the angle given in the diagram. So since this one is 20 degrees, so we make our vertical and horizontal component be included in your 20 degrees angle. So this will be your F2y, this will be your F2x. So again, by formula. So again, if you don't know the shortcut of the formula, so just try using the basic concept of your trigo. So let's say you have sine theta is equal to, again, that's opposite side of the angle over the hypotenuse. So opposite side is f of 2x, then hypotenuse is 80 newtons. So meaning the horizontal component of your force number 2 is 80 sine 20 degrees. And the answer is, so that's 27.36 newtons. So getting the other component, so using cosine function. So cosine adjacent of the angle, f2y all over 80. So that's f2y is equal to 80 cosine 20 degrees. So the answer for this one is 75.18 newtons. So we are done with the second force. So let's go to the third force. So the color is orange. So again, since this one is downward, force number 3 is equivalent to force 3y. So that's equivalent to 110 newtons. So again, your force 3x is not answerable because we don't have any horizontal component for force number 3. So that's 0. So lastly is your force number 4. So again, this one is this one here. So again, draw your triangle with the angle given in the problem. So since this one is your 15 degrees, so this one will be our x, this one will be our y component, and this one is 15 degrees. So again, that's 100 newtons. Then this one is for F4y, then F4x. So again, using basic principles, is that we're going to have your sine function first. Sine theta is equal to f, so f4. So again, sine opposite of the angle, that's your f4y. Adjacent of the angle, I mean the hypotenuse of the angle is 100 newtons. So you have f4y is equal to 100 newtons sine 15 degrees. So you have 25.88 newtons. So the horizontal component, so again 15 degrees, adjacent of the angle is this one, then hypotenuse is 100 newtons. So f4x is equal to 100 newtons cosine 15 degrees. So the answer is 96.59 degrees. So in solving your resultant, so again as per the previous slide, so we're going to solve first the resultant of x. So that will be f of 1x plus f of 2x depending on the number of horizontal forces that you're going to add up. So again, this time is we're going to add up only 3 because we don't have any horizontal force for force number 3. Okay, so that will be this one, 75 square root of 3 plus f of 2x, 27.36 plus f of 4x, that's here, that's 96.59. So the total resultant of x is so that's 253.85 newtons. So for the vertical components, that's r sub y. So f sub 1y plus f sub 2y plus f sub 3y plus f sub 4y. So that will be 75 plus 75.18 plus f of 3, that's 110, then f of 4y, so 110 is here, f of 4y is 25.88. So r sub y is equal to 286.06 newtons. So this will be your total horizontal force of the system. This will be the total, vertical force in the system. So notice na murag dako siya, di ba? And then notice in your diagram, so murag puro ta positive. So meaning ana, sayop ang ato ang pag-add up. So ano sayop man? So as you may notice, again as in the previous meeting, so di ba murag nag-add up ko daan dire nya, you didn't even notice nga sayop akong gibuhat. So ano sayop man? So again, if you look at your diagram, so again as in the previous meeting that I have stated, kay basta going all to the right, diba? All right forces are positive, all left forces are negative. All upward forces are positive, all downward forces are negative. So as you can see here, as what I did here in the resultant of x and y, so I just add it up tanan, diba? Which is wrong. So let's try to correct some of the values here. So let's try to erase the mga operations here. So for your f of 1, so all are positive, so that's correct. So positive, positive. Because it's going to the right, it's going up. So this one is a positive 75 square root of 3. So f of 2, notice that it's going to the left and going up. So meaning the only negative force here is the horizontal component. So this one is negative 27.36. So instead of plus, this becomes minus sign. And your vertical component is still plus because it's going up. In your force number 3, so since it's going down, so this one is negative component. This one is negative later, di ba? Then force number 4, it's going to the right, but it's going down. So you have a positive x component, but a negative y component. So this one is plus. So in the y component, this one is plus, this one is plus, this one is minus, this one is minus. So let me erase first the extra term here. Okay, so murag nakuan mo no? Murag, oh, sige lang, inyo rin ma-review sa recording later. So instead of 253 being the total answer, so we need to adjust it according to the direction of your forces. So 75 square root of 3, then minus 27.36, that's going to the left, 96.59. So the total resultant of x is 199.13 newtons. And for the vertical component of your resultant, the total is 14.3. Okay, so 75 plus 75.18 minus 110 minus 25.88. That's 14.3 newtons. So getting the resultant, so meaning since we have a positive value for your x and y component, so more likely your resultant force is in this direction. So 199, then 114 here, since all are positive values. And this one is your resultant force. So 14.3 here. This one is 199.13. So again, getting the resultant is we're going to use Pythagorean Theorem, rx squared plus ry squared. So resultant is 199.64 newtons. Okay, so if you want to get the angle, so again, you're gonna use tangent function. Okay, so I think it's a bit complicated, but I think you can just go with the flow here because I represented each force with a different color. So I think you can just follow through the discussion, or you can review this one later in the recording. So again, my tip here is you assign your operation sign or the signages of your forces, whether it's positive or negative, according to the direction so that you won't be mistaken in adding up the resultant of the x component and the resultant of the y component later. So asa akong ibuhat diri kani mga plus plus minus plus here na. So as long as you remember this one, so going up, going right is positive, going left, going down is negative force. And I think you can verify this one in the resultant of each of the forces. So this one is going up left, this one is going right up, going right down, going down. And I think by looking at the resultant of each forces, you can imagine the breakdown of its horizontal and vertical components. All right, so do you have questions? Or wala question kay naglibog na? Okay, so I think there's no question. So basi naglibog yun siguro, no? So just try answering the example again in your own. I mean on your own and with the guide of this recording later. So again, if we try to break down the components, so this one is a summarized version. So don't be confused with the I and J. So in vector terms, I is the horizontal direction, J is the vertical direction. So this representation here is more of a physics na vector. So muna siya ang pag-present sa inyong vector forces in physics. I, J, K na I in the x direction, J in the y direction, and if you have K, which is the advanced version, that's the Z component. You have a 3D force system. So X, Y, Z. So I think all of our answers are correct so far. So 199.1, then we have 14.3, and then all are positive. All right. So if you want to determine, so this one is the resultant of your system component earlier. So if you want to determine the angle or the direction of your resultant force from the x-axis, so again, what we need to do is we just have to use the tangent function. So again, from the from the diagram here, this one is your rx. So if you try to transfer your ry here to make it a right triangle, okay, so this one is in this figure now. So kamo na bahala sa akong drawing nga kay sa kamo sabot ana kay engineering na bata. So I know you're architects, future architects, so your drawings are a bit better than mine or at best siguro, iba compared to my drawing. So 14.3, then this one is 199.1. Then this one is your angle alpha. So again, if you try to determine the angle going to your resultant force, so let's say this one is your x-axis, and this one is your y-axis, x-axis, y-axis. So again, using the tangent function, so automatically your equation becomes, so again, opposite the angle. So again, instead of theta, since the problem is alpha, so let's try to make it alpha. So again, opposite the angle, adjacent of the angle. So tangent is opposite side over adjacent side. So opposite side is your y component of the resultant force. Then the angle adjacent to your is the horizontal component of your resultant force. So solving your angle alpha, so you have 14.3 all over 199.1. So angle alpha is, so again, by using your calculator, obviously, di ba, mas dali yung mag-use of calculator. So the angle is 4.11 degrees from the x-axis. Okay, so that's the direction of your resultant force from the x-axis. So again, take note that this one is from the x-axis. And this one is the answer, diba? So getting the resultant force. So the resultant force is this one was what we have solved earlier. And then this one is the direction of your angle 4.1. So this is how you write your direction. Angle then 4.1 degrees. So the magnitude of the resultant force plus the direction. So this one is magnitude. Magnitude. This one, oops. This one is magnitude. This one is the direction. So that's what makes your resultant a vector because it has a magnitude and it has a direction. Okay, so questions or clarifications so far? Hello, napamudya? Or nagduka na? Kaya nagbabuying na sa lunch ganina? Dawad siya motubag, nangatog na siguro ni sila. Okay, so no questions. Okay, so let's go to this last example go before we go to your assignment. So a hoist trolley is subjected to the three forces shown. So knowing that your A is 40 degrees, so let's try to put the value here in the diagram. So this one, as stated in the problem, it's 40 degrees. This one is 40 degrees. Okay. So again, the three forces are this one. So let's say this one is your force number one. This one is your force number two. Then your third force is unknown. The P. The P value is unknown. So again, that's three forces as being mentioned in the problem. So of course, what you see here is an FBD diagram, FB diagram, or a free body diagram of the hoist trolley. So you may not see a hoist trolley in the figure, but what you see here is the FBD of the forces, the free body diagram of the forces in the hoist trolley. So the problem is asking for the magnitude of force P. Okay, force P. For which, again, it's important that you read the problem because you may get some information from the problem. So the magnitude of force P for which the resultant of the three forces is vertical. So resultant of the three forces is vertical. Okay, and then the problem is also asking for the magnitude of your resultant force. Okay, so meaning your resultant force, so if we try to draw your resultant force, so that's a vertical, diba? So vertical going downwards because it is not going up because as you can see, all your forces are going down. And then since we're adding up forces, so it's right for us to say that the resultant force is going downwards. The resultant force is vertical, going downwards because of these two forces here. They are going down. And again, from the problem, it stated that the resultant of the three forces is vertical. So it's it's right for us to say that it is going downward in the y-axis because the two components here are also going downwards. All right. So if we try to imagine, since your force diagram is going down vertically, there's no, horizontal forces. So we need to how do you say this? Your Ry is a known value, but your Rx of the resultant is 0, right? Because since your resultant of the three forces is vertical, so we can say that the resultant, the horizontal component of your resultant force is 0. Okay? So meaning, if we try to break it, if we try to break this one even further, so meaning f of 1x, meaning the horizontal component of the first force, plus the horizontal component of the second force, plus p, the third force, should be equal to 0. Okay? So that's how you analyze the problem. So you read your problem step by step, or phrase by phrase or segment by segment for you to be able to get some data from the given problem. Okay, so I think nag-gets na ninyo? So did you get why your resultant force is going, vertically going down? So your Ry is equal to R Diana, since your Rx is 0. Okay, so let's try to solve this one. So if you try to draw your different force diagram, so let's start with the force number 1, the 2000 newtons. So again, this one is, so again, if you try to draw the components with the angle, so this one is the horizontal component, this one is the vertical component, this one is, so ito 40 degrees, no, that's 40 degrees. So 40 degrees. So again, this will be your F1x. This one is your F1y. So drawing your triangle first in the first force. So pwede na siya dili hidden line basta as long as you know the designation of the forces. So this one is 2000 newtons. This one is 40 degrees. So this one is F1x, F1y. So again, if we're going to use our basic principles of trigonometry, so let's start with the sine function first. So sine theta, sine alpha dahil kay alpha itong igamit. So sine alpha is equivalent to, again, opposite side of the angle, that's F1y, all over the hypotenuse. So hypotenuse is the longest side, which is the resultant force. So that's 2000 newtons. So meaning your F1y is equivalent to 2000 newtons times sine alpha, which is 40 degrees. So the first value is equivalent to 1285.58 newtons. So notice that this one is going downwards. So let's try to apply immediately your direction, the magnitude, or the signage of the direction of your force. So since it's going downwards, this one is negative. Okay, so next is we go to the second trigo function. So that's cosine ano theta mo jud alpha de alpha. Cosine alpha sa oops. So cosine alpha. Again, that's adjacent side of the angle. So that's F1x all over the hypotenuse. That's 2000 newtons. So the horizontal component is equal to 2000 newtons cosine 40 degrees. So your f of 1x, so again, since your f of 1x is going to the left, so that will be negative sign, negative 1532.09 newtons. Okay, so that's how you get the first components of your F1 force. I mean the vertical and horizontal component of the 2000 Newton force. So let's go to the second force, which is the 1000 Newton force. So let's try another color for this. So let's try green aside. So again, create the triangle along with the angle alpha. Di lang green kaya ang P may green. Sige, blue na lang. Okay, so again, create the triangle along with the angle alpha. So going down, then going to the right. So drawing the triangle. So what we have here is your triangle, this one, going down, going right, and then this one is your 1000 newtons. So 1000 newtons. This one is F2y. This one is F sub 2x. And then this angle here, alpha, is your 40 degrees. So again, with basic trig functions, starting with sine function. So sine alpha is equal to opposite side of the angle. So instead of f2y, that will be f2x. So again, as you notice, it's not the same as earlier. It will depend on the triangle that you have created. Kung asa puntahan nyo ang sine and cosine function. So this one is 100 newton. So again, notice that this one, the sine function earlier is f1y with the sine function. And then this one is we have f2, x, x. This one is x. So again, it will depend on the triangle that you have created, whether what side is opposite the angle that you have generated or that you are implying to. So since the opposite side of the 40-degree angle in force number 2 is the x component, so muna nyo i-follow. So ganina, the opposite side of the 40-degree angle is the y component. So that's your sine function. The sine function for the second figure is the x component. So muna, it will depend, again, it will depend on the diagram that you have created. Okay, so 1000 Newton sine 40 degrees. Okay, so again, since this one is going to the right, so the value is 642.79 newtons. Okay, so the other trig function is the cosine alpha. So that will be the adjacent side of the angle. So this time the adjacent side is the vertical component. So F2y all over 1000 Newton. So F2y is equivalent to 1000 newtons cosine 40 degrees. So again, since your vertical component in the second force is going downwards, this one going downwards, so this will be negative sign. So minus 766.04. So that's your value for the vertical component of the second force. Again, the problem is asking for the value of your P or the third force. So let's try to, so again, the problem is looking for the value of your P. So we don't know the value of your P yet. So again, as mentioned, the value of P having a resultant of a vertical force. So again, as what I have wrote down earlier, so since it's a vertical force, so most likely the horizontal force is 0. Okay, so this one is your F1x plus F2x plus F3x. So F1x is this one, negative 1532.09, negative 1532.09, plus the second the second horizontal force, which is your positive 642.79, 642.79. Then the third force is your F3x is your P value. So again, this one is equal to 0. So your P value is equivalent to, so negative 1532.09 plus 642.79. So the value is 889.3 newtons. So this is your answer of your third horizontal force. So since the problem is asking for the value of the resultant force, so again, as what I wrote earlier, so let's try to use the orange. So again, your resultant force is just equivalent to your vertical force. Since, again, since our vertical force is going down, so might as well add up all the vertical components. So this is F1y plus F2y plus F3y. So F1y is this value here. So that's negative 1285.58. And then plus the second vertical force, that's negative 766.04 minus 766.04. Then the third vertical force, since again, it's a horizontal force, so meaning that's 0 plus 0. So resultant force is equivalent to, so that will be negative 2051.62 newtons. So this is your resultant force value. Okay, so verifying the answer. So this one is the final answer. So kuha lang siya, rounded off lang siya. So 889.3, then the other one is negative 2052 lang ilaha dere. But our ours is 2051.62. So if you round that one off, that is still 252 newtons. So another way of representing your signages, so instead of negative and positive sign of the value of the magnitude of the force, so you may write it in this manner also. So all your values are positive, but you need to have your arrow represented on the right side. So as here, as mentioned here. So again, instead of negative 2052, so you may write it as a positive value, but you point or you indicate the direction of your magnitude. So it's going down, it's going up, it's going right, it's going left. All right, so do you have questions or clarifications? Hello? Wala na? Sige, sige. So, okay, so wala. So no questions. So for your assignment, so I'll give you an assignment since we will meet on next Thursday. So muna siya. So I posted your assignment sa Canvas. So what you need to do here is, again, I think it's the same as as what I have computed in the first example and in the second example. So what you need to do is to um, find the value of the x and y components. Then after is you determine the resultant force. Okay, so again, this one will be presented on your, I mean, published in your Canvas course. Okay, so since this will be only two problems, so the deadline for this one will be on next Tuesday. So syaro malate pa jud no nga two problems ra. All right. So for next meeting is we'll be discussing moments. So that will be in physics term that will be torque. So that will be the twisting of the material. So that will be discussed next Thursday. So if you don't have questions, so I think that's it for today.